Hello everyone, welcome back to our chemistry class. So we are still in chapter 4, chemical bonding. This is a video of 4.1 part B, and we are talking about the octet rule and the formation of ionic bond, covalent bond and dative covalent bond in this video. So in the previous video, I told you that the Lewis dot symbol is used to show the bonds between atoms in a molecule. So the question now is, why does atom need to form bonds? Actually, atoms achieve octet and duplet stability through bonding. So in this video, I want to introduce you with the octet rule. So the octet rule states that atoms have the tendency to give, receive or share electrons in order to attain the stable electronic configuration of noble gas, which is duplet or octet. In other words, the octet rule is the tendency of atoms to prefer to have add electron in the valence shell. Therefore, there are three ways for an atom to achieve a noble gas electronic configuration. The first one is losing or donating the valence electron. The second one is gaining or accepting electrons, and the third one is sharing electrons. Donating and accepting electron happens when ionic bond is formed, and the sharing of electrons happens in the covalent bond. Let's take an example on how the transfer of electrons and also the sharing of electrons happen in the octet rule. Okay, let's say we have lithium atom and also fluorine atom. We know that lithium atom has 1 valence electron and fluorine atom has 7 valence electron. Therefore, lithium will donate 1 electron to fluorine atom so that lithium can achieve duplet stability and fluorine will achieve octet stability to form lithium plus and also fluorine minus. So this will form the ionic bond between the lithium atom, the lithium ion and also the fluorine ion. Next, for example of sharing of electrons, let's say we have fluorine atom to fluorine atom. So what will happen? Each of these fluorine atom will share one of their electron. So they will form a covalent bond in which when the covalent bond is formed between them, each of these atoms will reach octet stability. Now let's take a look in detail about the ionic bond, the covalent bond and also the dative covalent bond. The first one is the ionic bond, also known as the electrovalent bond. So the ionic bond is the electrostatic force of attraction between the positive and negative ions in ionic compound. So actually the ionic bond is formed when the electrons are being transferred between atoms to give electrically charged particles ions that attract each other. So for the formation of ionic compound, in order to achieve stability, metal elements will donate electron while non-metal elements will receive electrons. Thus, the metal elements will form cations while the non-metal elements will form anions. Please take note that the number of electrons transferred is equal to the charge of the ion. Let's take a few examples on how the ionic bond is formed. For example 1, we have sodium atom and also chlorine atom. So we know that sodium atom is a metal and chlorine atom is non-metal. Therefore, sodium will donate 1 electron while chlorine will accept electron. So the transfer of electron from sodium to chlorine is shown by using an arrow. So meaning to say, one electron from sodium is donated to chlorine atom. Therefore, sodium will bear a positive charge while chlorine will bear a negative charge. Make sure to write a bracket, okay, to show the formation of the ionic bond, and then you need to write the valence electron for chlorine in the bracket. Next, for the second example, we have magnesium, atom magnesium, and also atom oxygen. So we know that magnesium is metal and oxygen is non-metal. Therefore, magnesium will donate electron and oxygen will accept electron. So magnesium will donate 2 of its valence electron to oxygen so that it can achieve octet stability, while oxygen will accept 2 electrons from magnesium so that it will achieve stability, octet stability. So magnesium will bear the charge of 2 positive and oxygen will bear the charge of 2 minus. Next, for the formation of lithium oxide, how about you try to draw the ionic formation between lithium and also oxygen, and I'll show you the answer later. So this is how you write the ionic bond formation between the lithium and oxygen. Good job on getting it right. So this is the properties of ionic compounds. The first one, ionic compound is solid at room temperature. It has high melting and boiling point. It is soluble in water. And also the molten ionic compound will conduct electricity because of the presence of mobile ions, free moving ions, which is in the form of cations and anions. Next, let's take a look at the covalent bond. So the covalent bond is the force of attraction between the nucleus and their shared electron. So actually, covalent bond happens if the atoms have similar electronegativity. Therefore, they cannot react with each other by transferring the electrons. Thus, the atoms will share electrons so that they can achieve the stable electronic configuration of the noble gas. So, the formation of the covalent bond only involves the non-metal atoms. Let's take a few examples on how the covalent bond is formed. So, in this example, we have 2 chlorine atoms. Okay, 2 chlorine atoms will share 1 electron. Okay, when they share 1 electron to each other, they will achieve octet stability. So there is a second way to write this covalent bond. So this is the second way to write the covalent bond. That bond is called as the single bond, and please take note, in a single bond it has 2 electrons that are being shared between the atoms. Now let's take a look at few examples on how the single bond, the double bond, and also the triple bond in covalent bond is being formed. Let's take a look at example 1, the single bond. So the single bond is formed in the molecule of water. So as you can see there, hydrogen will share 1 electron with the oxygen. Okay, each hydrogen atom will share 1 electron with the oxygen atom to form a single bond between the H and also O atom. Second one, we will take a look on how the double bond is formed in the covalent bond. Please take note, in double bond, the 2 atoms will share 2 pairs of electrons. So let's take a look at the formation of carbon dioxide. So each of the oxygen atom will share 2 pairs of electron with carbon. So the sharing will form double bond between the oxygen and also carbon atom. So there is 2 ways on how to show the double bond. The first one using the double lines as shown, and also you can use the dot to show that 2 pairs of electrons are being shared. Next, let's take a look on the formation of triple bond. So in triple bond, 2 atoms will share 3 pairs of electrons. So we have 2 nitrogen atoms here. So each of these nitrogen atoms will share 3 pairs of electrons to form a triple bond. So you can use the dot symbol to show the triple bond, or you can use 3 lines to show that 3 pairs of electrons are being shared between the nitrogen atom so that it could achieve stability. Now let's take a look at the length of covalent bonds. So we have C single bond C, C double bond C, and C triple bond C. So when we compare these 3 bond types, the C triple bond C will have the shortest length of bonds, and the C single bond C will have the longest length of bond length. Okay, the same thing also happen between the C single bond N, C double bond N, and also C triple bond N. So C triple bond N will have the shortest length of bond length, and C single bond N will have the longest bond length. Okay, so we can conclude from this data that the triple bond will have the shortest bond length, and the single bond will have the longest bond length. Last but not least, let's take a look at coordinate covalent bond, ataupun kita boleh guna dia sebagai dative covalent bond. So the dative covalent bond is formed when one atom provides 2 electrons which are then shared with another atom. The atom that provides 2 electrons is what we call as the donor atom, and the atom that are being shared the electron with is called as the acceptor atom. So the donor atom must have a lone pair electrons, while the acceptor atom must have empty orbital or unfilled orbital to accommodate the 2 electrons. The bond is represented by an arrow, and that arrow is coming from the donor atom to the acceptor atom. So actually, dative bond will possess similar properties as the normal covalent bond in terms of the bond strength and also the bond length. So let's take a look on how the dative covalent bond is formed in the ammonium ion. So as you can see there, the ammonia have lone pair electrons, therefore ammonia will become the donor atom. And for H+, as you can see, when we draw the orbital diagram for hydrogen and also hydrogen ion, we can see that the hydrogen ion have empty orbital that can be used to accommodate the 2 electrons from the ammonia. So H+ ion is the acceptor atom. Therefore, the ammonia atom will provide 2 electrons to be shared with the H+ ion. So it will form a dative covalent bond. So kita just salin sahaja balik HN dengan H itu. Lepas tu kita akan buat satu anak panah daripada nitrogen pergi hidrogen, menunjukkan bahawa itu adalah dative covalent bond, yang mana N adalah donor atom dan H adalah acceptor atom. So kamu kena draw juga bracket dan juga charge positif untuk menunjukkan bahawa ammonium ion ini adalah bercharge positif. Next, you are given ammonia and also boron trifluoride, and you are asked to draw the dative covalent bond for this molecule. So as you can see there, the ammonia is the donor atom, okay, and then the boron trifluoride will become the acceptor atom. So the donor atoms will provide 2 electrons to be shared with the boron trifluoride, and this will form a dative covalent bond. So this is how we write the molecule of ammonia boron trifluoride, in which there is what we call an arrow from the donor atom to the acceptor atom. Next, let's take a look on the formation of dative covalent bond of Al2Cl6. Okay, this formation will involve 2 molecules which are AlCl3. So, in this molecule, chlorine atom will become the donor atom and aluminium will become the acceptor atom. So what will happen? Okay, chlorine, okay, lone pair of chlorine will be provided, okay, to be shared with the aluminium atom. So actually, in this dative covalent bond, there will be 2 dative bonds will form. So we write the first molecule of AlCl3 first, and then we write the second molecule of AlCl3, and 1 lone pair will be shared with the aluminium atom. And then after that, kita tulis balik sahaja lone pair untuk chlorine atom bagi molekul AlCl3 yang pertama. And then untuk molekul AlCl3 yang kedua, kita tulis balik Cl atoms dia. Okay, and then we know that Cl atoms, 1 Cl atoms pada molekul AlCl3 yang kedua akan provide 2 electron to be shared with the aluminium in the first AlCl3 molecules. So, di sini kita boleh nampak ada 2, okay, ada 2 dative bond yang terhasil untuk dative covalent bond Al2Cl6. Next, how about you try to draw the formation of dative covalent bond for the hydroxonium ion. I will share the answer in a moment. So this is the answer on how to write the dative covalent bond for the hydroxonium ion. Good job on getting it right. So that's all for this video, guys. So if you are interested for the PDF notes that I use in this video, okay, you can check the link in the video description below. Thank you for your time, guys. I'll see you in the next video. Take care and bye-bye.